Generally speaking, electric locomotives tend to be more practical, economical, and efficient than steam locomotives. No faffing about shoveling coal and building steam, just connect to the mains and off you go. There was one man, however, who was so convinced of steam power that he spent his life trying to design a steam locomotive that could outperform any electrical equivalent. And he succeeded. Born in 1892 in Lorry, France, André Chapelon grew up to become a keen engineer, studying at École Centrale Paris and serving as an artillery officer during the First World War before returning to complete his degree as an engineer of arts and manufactures. Naturally, Chapelon was interested in locomotive development, and in 1921 started working for the Paris Railway Company in Lyon and the Mediterranean as a probationer in the rolling stock and motive power department, with the hopes of designing his own engines. This job only lasted until 1924, when he left due to conflicting with management. He moved on to the Industrial Telephone Company that same year and quickly became an assistant manager before returning to work with trains again in 1925, when he was invited to work for the Paris Railway Company in Orleans. The company was finding the performance of their 3500 class Pacific engines to be disappointing, and so having a particular interest in thermodynamics, Chapelon set about improving them by working on and refining the fundamentals. Chapelon and Finnish engineer Kyösti Kyläla worked together on a new exhaust, and in 1926 they created the Kulchap exhaust. This alone greatly improved an engine's performance by reducing back pressure, and combined with a few other slight modifications made the 3500s, and later the 4500s, significantly better performers. Encouraged by this success, Chapelon continued to develop and improve locomotive designs, but rather than experimenting with new features trial and error style as most other engineers did, he decided to study how locomotives operated and sought to refine and perfect the fundamentals. This approach gained him international fame in 1929 when he took one of the 3500s, number 3566, and enlarged its steam circuits, increased superheat, added a feedwater heater, thermic siphon, lent poppet valves, and fitted a double chimney with two Kulchap exhausts. With just these basic modifications, the engine's indicated horsepower had gone from 1,850 to 3,000, an improvement of over 60%. On top of that, its fuel and water consumption improved by 25%, results that were practically unheard of at the time. Following this, Chapelon continued his pursuit of using his knowledge of thermodynamics to make the engines under his charge as efficient and as powerful as possible. By improving efficiency, he could squeeze more power into smaller engines and more energy out of every ton of coal burned. He also used compounding a lot in his designs, where steam from high-pressure cylinders would be exhausted into low-pressure cylinders to be used again, deriving more driving power from the same amount of steam. On top of that, by making steam passages wider and improving how steam was distributed and flowed through the valve gear, he effectively optimized how the energy was transferred from the boiler to the wheels with the least amount of energy loss. Using these principles, he experimented on another Pacific in 1932, converting a 4500 class into a 480 for use pulling expresses on lines with grades of 1 in 100. The boiler was the same kind used by the Norse Super Pacifics, with a long, narrow Bell-pair firebox, and combined with Chapelon's brand of compounding and superheating, it was able to achieve a thermal efficiency of 12.8%, an incredible feat for a steam locomotive. The final product was an engine capable of pulling an 800-ton train uphill at 95 km an hour and on level rails at 140. A further 11 4500s were modified this way, and another 25 were built from scratch for use elsewhere in the country. His follow-up engine was an even more impressive beast. It was all well and good making fast engines, but Chapelon also had a go at making a slower, stronger freight engine with the goal of maximizing and maintaining steam production at lower speeds. A 6000 class 210 was selected and rebuilt into a 212 with a whopping total of 6 cylinders. 4 low-pressure cylinders were positioned at the front of the engine while a high-pressure pair was mounted a little behind them. It was completed by 1940, but the Second World War resulted in trials being delayed. When it did perform, however, it didn't disappoint. It could handily pull a 1,600-ton train up a grade of 1 in 125 at 30 km an hour, with no help from a banking engine at all. And despite its disposition as a freight engine, it was capable of single-handedly pulling express services at 90 km an hour that usually needed to be double-headed. By this point, France's railway network had been nationalised, and Chapelon had been made part of the SNCF's engine repair division specialising in steam locomotives, his job essentially being to look over all the engines the railway had absorbed and modify the designs to keep them up to date. Chapelon had taken a trip to the US in 1938 to visit both the Alco and Baldwin locomotive works and learned a great deal about locomotive design, and as such was tasked with creating a series of locomotives for the SNCF that would combine American robustness with his incredible thermodynamic characteristics. The war naturally got in the way of this project, and in the meantime several classes were rebuilt using Chapelon's principles to get some more mileage out of them. Eventually, Chapelon got the chance to get back to doing what he did best in 1946, when he began work on a long-time ambition. Engine 241101 was a 482 locomotive built in 1932 by the State Railway Administration for passenger work, but also somewhat as a showpiece. It had 3 simple expansion cylinders, 1,950mm driving wheels, a powerful boiler, and was equipped with modern features such as an automatic stoker and equipment that would help save on fuel and water. It had a top speed of 120 km an hour, and while it was capable of doing the work needed of it, it suffered from multiple technical problems and did little work as a result. Chapelon felt there was great potential in the engine and began work rebuilding it in 1938. Finally, it was completed in 1946, and the end result was a 484 with a set of compounded cylinders, a new boiler with a steel firebox, improved superheater, reinforced chassis, and Chapelon's signature piping topped off with 3 cool chap exhausts. The end result was a truly spectacular looking machine, classed as 242A1, and testing began that year, with the only real hiccup being cracks forming in the high pressure cylinder block. This problem was quickly amended and it entered service in 1951. And what a machine it was! During testing, it managed to develop roughly 5,300 indicated horsepower, reach 110 km an hour while pulling a 700-ton train uphill, and topped out at 158 km an hour on level ground. Not to mention that with Chapelon's modifications, it was surprisingly economical. So much so that supposedly it transferred energy from the coal to the wheels more efficiently than if the coal was burned at a power plant, turned into electricity, and used to power the motors in an electric engine. The engine was Chapelon's magnum opus and remains the most powerful steam locomotive to have ever been built in Europe and possibly possessed the highest power-to-weight ratio for a steam locomotive ever. Alas, the rest of the SNCF didn't see it that way. For as long as he had worked on the railways, many of Chapelon's peers seemed to have a chip on their shoulder when it came to his machines. Higher-ups often tested him by giving him mediocre locomotives and limited resources, with which he always seemed to pull through in improving them. What made his engines so cost-effective was that they were rebuilds of old machines, only replacing what was necessary while still using what was already there. Chapelon frequently showed up his peers as a result, which often led to his engines being sidelined out of embarrassment. 242A1 was possibly the biggest victim of this, as the SNCF had already decided to move forward with electrification by the time it came into service and cancelling the other engines Chapelon had designed. When the numbers came in, the electric locomotive department found the engine would easily outperform the express locomotive they were working on for the line between Paris and Lyon, and had to amend their design to squeeze in another 1,000 horsepower. So in a way, its mere existence forced the SNCF to make better electric engines to compete with it. The railway directors too didn't like being shown up in this way, and in 1955 the engine was put to one side before quietly being scrapped in 1961 after Chapelon left the company, the 12-wheeled freight engine also being a unique design suffering a similar fate. Tragically, 242A1 was high on the priority list of engines to be preserved at the French Museum of Railways, though a handful of Chapelon's other engines still survive to this day. André Chapelon remained an avid railwayman for the rest of his life, eventually passing away in 1978 at 85 years old. Though his peers may have tried to tarnish the reputation of him and his engines, his impact on railway engineering was felt far and wide. He published several books on railway engineering and acted as a consultant for multiple foreign railway companies looking to build their own efficient locomotives. His research even helped in the development of the electric TGVs, some of his design features still being used to this day. Several medals and honours were awarded to him for his work, and he even became vice president of the Stephenson Locomotive Society in 1971. Nigel Gresley drew heavy inspiration from Chapelon when it came to designing his Pacifics, and many engineers around the world regarded him as a sorcerer when it came to locomotive efficiency. Livio Dante Porta, a peer and protege of his, went on to design and develop his own super-economical engines, which in turn helped lay the foundations for Red Devil and the modern advanced steam movement. If it wasn't for his work, engines like Tornado may have never come about. So let us modern steamheads take a moment to be thankful for Chapelon's work, as without it we wouldn't have some of the amazing engines we're blessed to have today. Just goes to show that you don't have to have all the bells and whistles to be incredible. Simply master the fundamentals and let the results speak for themselves. Subscribe for more.